Welcome to a new test and teardown video. This time it's a power supply from B&O, Bang & Olufsen. This one is called SN16A. It's a 3-in-1 power supply, 2 variable, 0 to 30 volts 1 amp, and a fixed 5 volt 3 amp. So the meter switch is here. You just change between the 3 outputs, and this one is modified with nice and shiny light. That is sexy. And the voltmeter switch, all the LEDs there are also changed, because normally you can't really see the LEDs anymore because they used really dim LEDs. I really like the green LEDs for the 3 outputs and for the 3 meter settings, and of course red LEDs for current. They're all normally red, so this is also a really great upgrade. So let's look at how this works. Let's take this one. So let's look at the voltmeter and let's look at the pot meter here at the same time. So I'm going slowly, see, and all the way up with the pot meter, and it goes to 30. So that is great. Yeah, it seems like this pot meter here is working. That one is great. Good. Approved. Let's take the right one. And I'm gonna do the same. Ooh, you see this? So it's full of did you see that? So this is full maximum. Ooh, I see. When I move the pot a little bit, it actually goes to a voltage more than maximum, and it happens in between here as well. All the movements you see here, that's actually the slider in the pot meter disconnecting, and every time you see this jumping, it's actually outputting full maximum voltage rail and not a regulated voltage that is maximum 30. And that is a design flaw in this power supply. With the pot meter open, the voltage gets to unregulated maximum voltage output. So that is something to address, or at least change the pot meters to a very good quality type that will not open when it is getting older. It needs to be always good contact. Look at that when I'm... We also got other design flaws in this. We're going to dig a little bit into in a minute. We're going to test a little bit with the current and loads and see what this can do. There isn't any settings for the 5 volt. You can't do anything. It's always 5 volt 3 amps. So what happens when this is overloaded, or how well is this regulated or protected? We're also going to see that. So now we're ready to test the 5 volt output. So this is a 3 amp output, and there is no load at the moment. And let's start with 0 amps, and the voltage is 5032. Okay, let's note this down. 5032, 0 amps. Okay, so let's crank on 1 amp. And let's see, the meter reached 1 amp. That is fantastic. And we got 5028. We don't want any more digits than that, do we? No. So that is 1 amp. Let's go to, oops, that was difficult. 2 amps. And the meter reads a little bit depending on where you are sitting. Yeah, okay, but this is close enough, isn't it? So that was 2 amps, and it is 5025. 5025, 2 amps. Let's try and see if this can do 3. Yes, it can. Ooh. So that is 3 amps, and we got 5.020. 3 amps. We're gonna leave it like that because it's supposed to deliver that. The voltage here is a lot less because this is the voltage measured here where the current flow. I actually got sense wires in the other half of this hook because I'm trying to make it as good as possible. But of course it is better to measure the voltage all the way up here. But I am still pulling current through the voltage measurement points because there is no way to separate this. There is no sense out or anything else. And yeah, the good old connectors with the screw type, you could actually pull the current in the middle and then measure the voltage, or the other way around, and this will give you a much better reading. So we're going to keep it like this for half an hour and see what happens. I will get back. So that was that 1 hour. It is still running with 15 watts of output, and it's about 47-48 watts of input. So that is 32% efficiency, and it is running a little bit hot. This is the heatsink is divided into 3 different heatsinks. This is ice cold, medium, and actually not that. It's not that hot. Let's try and do something smart. Let's look at the heat sinks. See, that will be the 3 heat sinks, and obviously, so it's 55 in there. So, and that is not, of course, at the end where you can touch. So you can't touch anything that is burning hot or dangerously hot, because if you go like this, it's only 40 something, not dangerous at all. I just called an expert who said, please don't load all the outputs at full power, and especially or not for a long time. There are different versions of this with different rectifier diodes and stuff. So I was recommended open this and check the rectifier diodes, and that is what I will do, and we'll see how much they heat up when I load all the other outputs at the same time. So we are about to open this. It's done by the 4 screws at the side, and then scroll out the top of the casing. There's another thing I really like with this this model and a lot of other B&O equipment. That is the service access to the PCB. Isn't this just fantastic? So you don't need to disassemble the entire unit. You can just remove the service access and service something. Also, there's another thing we really need to know. See? The isolated mounting of the 3 heat sinks. And that is because there's actually positive supply voltage on the heat sinks. So they cannot touch anything metal. That will be a short circuit. I actually didn't know about the type. It's also a type 9275. That's a little bit interesting. Okay, now it's open and we can see the internal parts. I'm trying to have a little bit of a look of how hot parts really are. And oh my god, this is, I guess this will be the big boy rectifier for the low voltage, high current output. And that one is just really warm. not so much on the heatsink, but if we look under the heat, let me see if I can get under the heatsink here. Look at that. So it's 110 if I hold this, yeah. So 110 if I look in here. So that means the diode here is not really well connected to the heatsink. There's a lot of loss somehow, so that is not working. Also, I find some resistors down here, and they are really hot as well. See, 80, and this will be that one. Yeah, that will be the transistor. So that means the heatsink is really doing its job. This kind of work. We also see some other stuff down. What is hot down there? Some other diodes are down there, or resistors and stuff. But look at the 3 capacitors here. That is a little bit worrying. They are of course shiny, as you can see here. So it's really difficult to photo or to infrared. Well, that first one here is like 50 Celsius. I added some paint on the top, so that means I can take the temperatures. I also think that I didn't add enough paint here on the top, because when I touch this one, I'm burning my fingers immediately on this capacitor. So this is definitely not meant for constant loading at full load. So what I'm going to do is I'm going to leave it on for a few hours and just see what are the temperatures in idle open. So this is the heatsink for the rectifier. I just removed it, and as you can see, this is a flat surface, and this is a flat surface and some metal with some thread. And what? 4 normal diodes like that? There's absolutely no thermal connectivity, you know. This is never gonna work. And this is of course why they are 110 Celsius hot. When I was looking with the thermal camera in here, I could see the ends. They were that hot. This does not work at all. And this screw is the PCB mounting, so it's nice and stable in this corner. All they should have done is remove this corner and put a normal, 4-pin bridge with a screw mount in the middle, and bada bing bada bum, everything would have been done, and they would have saved all the trouble with all this, and with this piece of metal and the bendy and screws and stuff. And also, if you look at the other diodes, it looks like somebody changed this diode. It's not the same as the others. So I guess those will be the 2 bridges for the 2 1 amp. Or is it those? I don't know. Now I'm gonna try and load the 1 amps outputs and see if that is what we're talking about. I added some more paint, so now I can see some more thermal. But I really like the way they put the fuses and on the AC on this interconnect board. So when you just unplug this board and then take this out, we got all the fuses here. And of course, the failure mode for diodes, that will be shorting. So if they short, of course you want the fuses to be on the AC side, where they are nice and convenient, accessible. So this is really a good thing. There's also another mod we need to talk about. This is a 3-wire mains with earth connection, and this is not how they were normally or originally made. So this is also a very important upgrade to do. If you got power supplies from B&O, any of them, please make the earth connection to the chassis. This is very important because there's quite a high capacity coupling from the mains side to the secondary side, and if you don't do this, you're going to have a half voltage mains on your chassis, and it's gonna couple directly out to the circuit you're trying to power. So it is lethal to a lot of electronics. And by the way, this mod is just for the LED. So that is yeah, just for that, yeah, super simple. So it has been running for quite a while in idle mode, and we will see it is using about 5 watts in total. And so the power loss in idle is distributed like this, where we can see the mains transformator is quite big, and there's a little bit of temperature in that one. We also got something down here that is warm. What is... I need to do it better, I guess. What is that? We got the resistors. Okay, those 2 resistors are 51 and... what is the other one? Okay, yeah, R51 and 52, and it's probably R50 as well. So all the different power supplies, they're more or less the same design. Let's see, yes. That is definitely that. And this is idle, 82 degrees. Ui, ui, ui. How hot is that one? 64. So those 2 are the same. So that will be the 2 30 volts, and this will be the 5 volt output. So those resistors still, they're just running, burning hot all the time. So that is the main use of power. What else is hot here? Let's see. Whoa, op amps. What is that? We got a component down here. Hey, this is annoying with the light. Where is it? So that will be the capacitor. Okay, down here. Yes, see? There's 1 resistor here. That is really, really warm. It's one of them over here. But other than that, there's nothing to be afraid of. Yeah, the other IC here is also a little bit. Really? 40. Yeah, okay. So that'll be that. And that resistor R2. Yep. Definitely. Oh yeah, and that is a Zener. Pretty cool. And also, look at the modifications done to the 2 op amps for the voltage regulation. I will put a link to a web page that explains exactly how and why this is done. There's of course another design error when you turn around the... Ooh, you see this? That is because this pot is quite tired. But anyway, when you crank around with the voltages, or if you have a capacitive load on, it's possible to put this power supply into a lock mode where it just puts out full voltage on its output, and it's not able to get out of this again by itself. So there's a problem in the way that they designed the circuit, and this is explained in the link. So please fix that, and it's actually the same circuit in all their power supplies, and this should have been fixed, along with the way that the pot meter here is open and you get full voltage output. But there's actually another little trick we can do, because if we look at the pot meters, it'll give me some light, and there was light. See, the last pin of the pot is not used, so the guy who replaced those pots here didn't know about this little thing called this the lever release problem, right? So if this the sensor pin is connected to the outer not used track. That means when it lifts by error, you will at least have the resistance in the full resistance and not an open at least. So that is a trick to do. Oh yeah, this is also modified with some really big and strong diodes. This is not normal as well, so that is a good thing to do on the two DC outputs. Normally I think it's located on the other side, but of course they blow up when you connect a parallel or serial them, or whatever you do wrong, you're gonna blow up the original diodes. Let's try and play a little bit with one of the 30 volt outputs. I tried to look at the voltmeter as good as I could and adjust for exactly 30, and then let's see, 30.33. That is pretty good. So let's try and give it 1 amp. Okay, so the amp meter shows a little bit to the low side, but I think we can adjust this here. This will be the meters. Those adjustments, I guess, or this is the current. Okay, here we got the current limits. So this will be, this is something I need to play a little bit with, so see if this is what this is before I start to play clever. But 1 amp and 30 volts, the output actually dropped quite a lot. So this is 1 amp load. Let's turn it off. Okay, open, and then 1 amp. So I guess this has something to do with the way that I'm connected here, because this, yeah, it is. This is not how you do that, right? It's better to actually put the voltmeter behind here. Of course, you don't have this access, but yeah, I don't know what to say. But I'm gonna see, let it run a little bit and see how hot it gets. So this is wow, this is 30 watts output, and I'm using 50 watts input. So that is better. So it's only been running for a few minutes. Let's have a little look. So this is just the proof that it's only been running for a little while. So we still see the op amps, and that is of course the series regulator. That is nice and warm here. It's difficult with a slide. Yeah, this is the rectifier, and it was actually the ones that I painted here. That will be the power rectifier for the two 30 volt outputs, and this one is running really. Oh, let's put on the macro lens. Then we can really. Oh, come on, man. We can then I need to turn this light. All I try to do is get this 97. Whoa, that is really. That is a little bit too much, isn't it? So that means it is definitely the diodes that is the weak point when it comes to lifetime in this power supply. So all I suggest is to fix those diodes and those diodes, and you can beat this up all day long if you want to. So that was actually what I wanted to show. Yep, it was right. That was super easy to adjust the two different current outputs or current readings. So it says here 0.8 and 0.8, so I assume they only want you to adjust for maximum accuracy at 0.8. Well, what I did is I adjusted it at 1, and then I double checked 0.5. See, this is 0.5, 0.7, 8, 9, 1 amp. This is extremely accurate. The amp meter, I'm super happy about this. And the voltmeter, again, let's try and adjust it again. See how accurate this is. This is as accurate as I can make it 30, and this is 30.3. Very, very good. I just tested the 3 amp output. So this is 3 amp. I guess this will be the adjustments for the, yes it is. So this one is the 3 amp meter. So let's make this as accurate as we can. So the next problem is current limit. As far as I can see, this one is the adjustments for the voltage, but there's also a 5 volt here. So what exactly, which one of them? Oh, let me turn off the load. Which one is doing what? Is this the voltage? Okay, this is the voltmeter. So this one only changes the readout. Okay, and I got 5 volts. So I will change the readout here so it is as close to 5 volts as I can. So I mean, this one down here is probably how much volts you get, right? Yes, it is. So now we got 5.00. So that's pretty good. But where is the current limits set point? Because this thing gives almost 4 amps before it shut down. And this is not what I want. I found it. Let's show you guys this. All those resistors down here, those are the sense resistors where all the 3 amps go through, and it is feedback to the regulator. So the only way to adjust for how much or how little maximum current you want in the overload protection is actually to cut one of the resistors. And this is mounted with all of them, so that means it gives maximum, and that is actually a little bit too much. So this one can give nearly 4 amps. So all I have to do is cut one of them, and then we'll be fine. You can also see right now I'm pulling 3 amps. And then I have to remove the lamp. Yes, thank you, go away. And here we see the sense resistors. See, that was actually quite fun. I cut away one of the sense resistors, and now it shuts down at 3.2 amps. So this is exactly what I want. But of course, those sense resistors are of course also a part of the amp meter. So the amp meter needs to be adjusted again. And now we got 3 amps again. Fantastic. Let's try to see what happens. So that was 3 amps, 3.1, 3.2, and 3.3. Poof. Output turns off, and it's in constant current mode. And let's go down again. Let's see, that was 2 amps. Yeah, it's really, really good now.